you talked last night about small packages, thinner packages. The audience there is test people, consumables people. What do you see as the impact of these thinner, smaller packages on test?
Right. So when people are thinking about the impact of thin packages in terms of how the test contacts or test parameters may be going into, it's obviously a mechanical challenge. So you're dealing with much more delicate components, many components that may used to have balls, just have lands on them. Packages that used to have a mold compound surrounding them may just have just a bare die. So these challenges aren't specifically new. It's just people are, as the packages get thinner and thinner, they get more and more difficult to handle. They become more and more fragile. And that poses a challenge from a mechanical perspective in terms of how much pressure you can put on the components on them as well. And that challenge exists not just for middle of the road die, but the challenge is extreme with very thin die, as well as for very large die for different reasons.
So you just did a lot of talking about the mechanical issues, but
Right.
there are also, as you alluded at the end, with the thinning in particular, also electrical issues. Talk about those for a few minutes.
So the electrical issues when you're dealing with thinner packages are a complex parameter. So often you're pushing chips to their limits depending on which test you're doing. So if you're doing a burn-in test where you're operating at high speeds, when you're dealing with thinner packages where there's not a lot of place for the heat to go, that can cause challenges. When you're talking about the electrical test, it can also, any stresses induced on the chip or something like that may impact the actual performance, which you're trying to imitate what's going to actually happen, but doing it within the configuration of the test socket solution that's available to them.
Okay. So I'm going to go two different places, but I'll do them separately. Think for a minute about the Internet of Things and all the sensors that it implies. And think about the implications of that on packaging and then test, right? Can you talk what you see there that's different, if it is, than thin or small?
Right. So the impact of Internet of Things, or more related to that, really comes down to what levels of integration people are going to be doing. So if you look at any smartphone or tablet today, there's certainly integration that's being done, but because of the incredible amount of functionality that's already built into those products, there's many more components. When you start thinking about wearables or Internet of Things, they're really dedicated performance or dedicated function devices. So you can imagine there'll be a lot more integration. And the very specific part of that is a single module that does the wireless, the RF, the sensing, and the processing. And I'm not sure anyone has gotten there, but people are taking the steps towards doing that. So the question becomes is, where is the test done? Is the test done on the die before they're integrated? Is the test done afterwards? And really, how is that done? From a test program perspective, it's a big challenge and an economic decision where those things may be being done, especially if the die are coming from different sources. So there's not one company that I know of today that makes a microprocessor, sensors, memory, as well as passive components. So integrating all of that together, which was normally done at a big system level or individual package level, the question is, how do you do that now that fits into a modular solution?